Okay, students. So today we are doing divisibility. Now, as you know, right, there are certain rules that we can follow to determine whether certain numbers are divisible by another number. What are the key numbers that we have to take note of? Let's take a look. We have to take note of 3, 9, 4, 8, 7, 13, and 11. Now, you might be wondering, why are we arranging the numbers like that, right? Why don't I put 3, then 4, then 7, then 8, then 9? And why not? Why do I put 13 above 11? Okay, the reason I'm doing this is because the divisibility rules of 7 and 13 are very similar. So that's why we group it together. Don't worry, you don't have to, you do have to memorize the rules, but because some of them are similar to each other, then you have lesser things to memorize to tell whether a number is divisible. So let's take a look at 3 and 9. They have the same rule. You just need to take the sum of their digits. So what's the meaning of sum of their digits? For example, students, okay, what is sum of digits? Okay, hold on. So what is the sum of digits? For example, students, if I want to determine if this number is divisible by 3, all I need to do is take every single digit and add them up. So I find the sum of their digits. And that will give me 1 plus 2 plus 3 plus 4 plus 5, which is 15. So I say, since 3 divides the sum of their digits, therefore 3 can divide the number itself. Understand? So what is the meaning of this line? It just means divides. So when you say 3 divides 1, 2, 3, 4, 5, it means that when you take 1, 2, 3, 4, 5 divided by 3, the remainder is 0. Okay, so just take note of the notation. Now let's take a look at 9. It's the same as 3. The divisibility rule is the same as 3. You just find the sum of digits, which is 1 plus 2 plus 3, all the way until 9, you get 45. Then we say, since 9 divides 45, therefore 9 can also divide 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. So the easiest rule, I think this is the easiest rule out of all. You just need to find the sum of digits. You'll know whether it's divisible by 3 or divisible by 9. Any questions so far before I move on to the next number, the next rule? Anyway, if you have questions, you know what to do, okay? Just raise your hand. Now, let's go back to the previous page and move on to the next rule. Divisibility rule of 4 and 8. So if you want to know whether something is divisible by 4, you just need to look at the last 2 digits. If you want to know if something is divisible by 8, just need to look at the last 3 digits. So let's take a look here. Let's find out if this is divisible by 4. Look at the last 2 digits. 56. Since 4 divides 56, therefore the entire number is divisible by 4. Okay, that means 4 divides 1, 2, 3, 4, 5, 6. And what about this? Look at the last 2 numbers. Oh, now I'm going to teach you another notation. Since 4 does not divide, this is does not divide. Since 4 does not divide the number 67, therefore the number 4 does not divide the number 1, 2, 3, 4, 5, 6, 7. Okay? So students, can anybody guess what's the remainder? Everybody, can you just type very quickly in the chat? What is the remainder if you take 4 divided by 1, 2, 3, 4, 5, 6, 7? What's the remainder? Very, very obvious, right? Yes, Kaden, you're correct. Vishwam, you're correct. It's obviously remainder 3 lah. Okay, so remainder will be 3. Because you look at the last 2 digits, you just take 67, you divide by 4, you know that the remainder is going to be 3. All right? So let's look at the next rule. Now, of course, if it's the number 8, you need to look at the last 3 digits, okay? Now, let's look at rule of 7. There are many ways to find out whether a number is divisible by 7. Okay? You take the last, let's look at the first way. Let's look at the first method. You find the last digit, you double it. Then you subtract the answer from the rest of the remaining number. Okay, we'll do this, don't worry, I'll show you an example. Another way is to separate the last 3 digits from the rest of n. Let's just say n is a number that you're trying to test. You're trying to test whether the number n is divisible by 7 or not. Okay, then you just take the last 3 digits of this number n, and you take the difference between these last 3 digits and the rest of n. Okay, we will do examples, no worries, no worries. Okay, so this is the second way. And the third way, okay, if you see a block of 6 digits, okay, let's say the number 6666666, a block of 6 digits, for example. Just take the last 3. You just, actually number 2 and number 3 are similar. The rules are similar. You just take the last 3 digits of n, right? Find the difference between the last 3 digits of n and the first 3 digits. So if it's 66666, then you just take 666 minus 666, and you find that it's 0. You know that 0 is divisible by n. I mean, 0 is divisible by 7. Because 0 can be if you take 0, you divide by anything, you'll never get a remainder. The answer is still 0. So 0 is divisible by 7. Therefore, the entire number 6666666 is also divisible by 7. So you can say the number 7 divides the number 6666666. Let's take a look here. 1, 2, 3, 4, 5, 6, divide by 7, and you will not be getting any decimals. You'll be getting a nice whole number. Am I right? Okay, great. So that's what we do. 666. This is the rule. Rule number 2 is actually, rule number 3 is essentially part of rule number 2. Okay, and for example, going back to the 6666, the example, why not I give another one? 666. Instead of saying 666666, why not I say 666659? So then you take the difference. Okay, you take the difference. 666 minus 659. What's the difference between the last 3 numbers and the rest of n? Oh, you realize it's 7, right? So if the answer is divisible by 7, then the entire thing, 666659, should also be divisible by 7. Let's take a look. 666659 divided by 7, and you will get a whole number. Okay, so that's the divisibility rule of 7. And 13 is exactly the same. Okay, for number 13, right? 13 does not have rule number 1. Okay, this is only, the rule number 1 is special for number 7. It's not for number 13. For number 13, you just need to follow rule number 2 and rule number 3, which is to separate the last 3 digits. Yeah? So let's take a look at the example. If I want to check whether 5124 is divisible by n, okay, let me use the first rule. Look at the first rule. Take the last digit, double it, and then subtract the answer from the rest of it. So let's take the last digit. The last digit is 4. You double it, and you subtract it from the rest of the number. Now, do you know whether 504 is divisible by n? Okay, some of you with very good mental calculation, maybe you know. I don't know. I don't know. So I'm going to do it again. I want to know whether this is divisible by n now. I take the last digit, I multiply it by 2, and I subtract it from the remaining part of the digit, remaining part of the number. And I get 42. And I know that 7 divides 42. Okay, I'll say since 7 divides 42, therefore 7 should also divide 5, 1, 2, 4. Let's take a look. 5, 1, 2, 4 divided by 7. And you get a nice whole number. Okay, students? And of course, the 666 example, I already used it just now. 666 minus 666 equals to 0 since 7 divides the number 0. Therefore, 7 divides the number 666, 666. That's how we do it. Okay? Questions? All right. Moving on. Number 11. Okay, so far let's recap. What have we done? Number 3 and 9, very easy. Add the sum of the digits. Number 4 and 8, I would say quite easy, right? Just look at the last 2 digits for 4. Look at the last 3 digits for 8. Pretty straightforward. Number 7 is, maybe I can say that there's a few ways. Number 13 also, very similar to 7. Now let's move on to number 11. You find the alternating sum. What is the alternating sum? I'll just demonstrate it, all right? Let's look at number 11 over here. Finding the alternating sum. It means positive. Okay, this is a positive number, students. Positive, negative, positive, negative, positive, negative. Do not make this mistake. Do not make this mistake. I'm asking you for alternating. And what is this? Over here, you have given me 2 positive numbers. I need alternating. 1 positive, 1 negative, 1 positive, 1 negative. Understand? So don't make this mistake. Okay, so anyway, that's the alternating sum. And what do we get? We are going to get -1. Uh-oh, I don't think this is divisible by 11. So you say that since the number 11 does not divide the number -1, therefore, the number 11 does not divide the number 784301. 784301 divided by 11. Oh, so many decimals. Okay. Now, what about another example? Let's take a look at this one. Alternating sum. 3 positive, then negative, positive, negative, positive, negative. And we are going to get 11. Since the number 11 divides the number 11, therefore the number 11 divides the number 316470. Go to the calculator. 316470 divided by 11, and you get a very nice whole number. Okay? Any questions? Okay, let's look at the number 13. Okay, you all still remember? It's very similar to the number 7. We have to look at the last 3 digits. We have to separate the last 3 digits from the rest of the number and find the difference between them. So I take the last 3 digits, I separate it from the rest of the number, find the difference between them. And I realize that since the number 13 divides 351, therefore the number 13 divides 12363, and we can test it out on the calculator. 12363 divided by 13, and you get a very nice whole number. What about this one? Same principle. Separate the last 3 digits, find the difference between the last 3 digits and the rest of the number. Since 13 divides 0, therefore 13 divides the number 5, 5, 5, 5, 5, 5. Basically, students, if this works, what does it mean? That means any block of repeated 6 digits, any block of 6 digits which has all the same number, they all can be divided by the number 13 and the number 7. Okay, come, let's take a look. 555, 555 divided by 13, it works. 333, 333 divided by 13, it works. You want to divide it by 7? 333, 333 divided by 7, it works. Any block of 6 numbers repeated, with all the same numbers, is always divisible by 7 and 13. Okay, the trick is to separate the last 3 digits from the rest of the number and find the difference between them. Okay, everyone, let's do some problem sums. Now, at any point you have questions, just raise your hands, okay? Now, they are talking about 313 and 426. They are divided by a whole number n. Okay, so you are dividing it by n. You don't know what n is. And you realize that the remainder is 17 and 19. Okay, no problem. That means if I take 3, for example, 313 divided by n, you will get an answer. Okay, let's call this the quotient. But I don't know what's the answer. They didn't tell us the answer. But they told us the remainder. The remainder is 17. Can I ask Zheng Yi? Okay? Zheng Yi, let me ask you something.
Okay.
Do you think the number 313 is divisible by n?
No,
Why?
because it's a remainder.
Yeah, because you get the remainder. How can I make the number 313 divisible by n?
Minus 17.
Minus 17. Very good. So students, if I take the number 313 and I subtract 17, the answer I get, now this number should be divisible by n because I already removed the remainder. There should be no more remainder. Okay, very good. Should I do the same for 426 also?
Yeah.
Okay, 426 minus what?
19.
Minus 19. So I'll get 407. Now these two numbers, I now know that these two numbers are divisible by n. Do you have any ideas on how I can find n?
Find the HCF of 407 and 296.
Excellent. Find the highest common factor. And the highest common factor should be the number n. So let's divide this by 37. Okay, then we'll get 8. Okay, I'm using the ladder method. Okay, we are supposed to divide until you can't divide anymore. Can I still continue dividing?
No.
Okay, so let's stop here. The HCF is 37. So we say n equals to the HCF of these two numbers, which will give us 37. Let's check. What are the two numbers? 296 and 407, right?
Yeah.
296 divided by 37. Okay, it works. 407 divided by 37. It works. Well done, Zheng Yi. Okay, so students, anyone has any questions about this? Then can I give you time to do practice number 1? Okay, everyone, can you please find the value of n for practice question 1 and type your answer in the chat? I will leave example 2 here for your reference, just in case you need to refer. Okay, I'll give you 2 minutes. Your time starts now. Okay, Talia, let's take a look. What should I do first? I realize that if I divide 473 by n, the remainder is 17. So how do I make 473 into a number that's divisible by n? What should I do?
473 minus 17.
Yes. So then that will give me 456. And this is divisible by n. What about 741?
741 minus 19.
Well done. So these two numbers are now divisible by n. All you need to do is find the highest common factor between 456 and 722, and you will be finding n. So let's use the ladder method. we call it ladder method because it looks like a ladder. So we
You
draw.
just gotta keep on doing the upside down divide even.
Yeah. So I'm gonna write down 4, 5, 6, 7, 2, 2. What number do you want to divide it by?
2.
Yeah. So if I divide it by 2, 2, 2, 8, 3, 6, 1. Let's divide it by what other number do you want to use?
Mm,
Well, it's gonna be, let's try a prime number, 19. So if I divide it by 19, I'll get 12 and 19. Can I continue dividing it?
no.
Okay, no. So if we cannot continue dividing both of them, then we will stop here and use these two numbers to find the highest common factor. I just need to take them and multiply them together. And what is n?
38.
Yes, Talia, very good. So how do you find it? Is this easy?
Mm-hmm.
All right, well done. So students, anyone have any questions? Raise your hand. Okay, for the ladder method, if you can continue dividing, just go on. Okay, if you can continue dividing, it will go on and on. You just need to take all the numbers on the left-hand side, multiply them together to find the highest common factor. Okay, it really depends on what numbers you use. The length of the ladder depends on what numbers you use and whether you can continue dividing them on and on. Now let's look at question 2. Why don't I ask Shiting? All right, Shiting. Over here, they're saying that when you take the number A and you divide it by B, the quotient is 2, 2, 1. The remainder is 19. So, since we know this, can I rearrange? Okay, let's rearrange this statement into an equation. For example, okay, let's just do ignore this for now. Let's just use another example for now. Why don't I take the number, let's say the number 91, and I divide it by the number 8. Come, what is the quotient? Let's use, okay, 8 times 1 equals to 8. So you minus 8. You bring down the number 1, it becomes 11. 8 times 1 minus 8. And we have a remainder 3. So we know that 91 divided by 8 equals to 11 remainder 3. So I can rearrange this to say that I can say that 91 equals to 11 times 8 plus the remainder. Do you agree? Shiting? So Nicole, do you agree with this equation? It works, right? Hello?
Yeah.
Can I do the same for A and B? If I were to rearrange it into an equation, what would I say? I would say that A equals to what? What times what plus what? Just imagine that this is your A and this is your B, right? So I can rearrange it accordingly. What will happen? A equal, yes.
8 times 11.
8. Let's not use the number 8. Let's not use this because this is just my example. I want you to focus on the question. This is the question. Let me rearrange. A equals to 2, 2, 1, what?
Times B.
Times B, then?
Plus 19.
Very good. Okay, come, let's write it down properly and let me get rid of the other example. So this is just an example, okay? So we know that A equals to 2, 2, 1 times B. So we have 2, 2, 1 B plus the number 19, which is the remainder. Now, do you agree? Now, the question is actually quite simple. They're asking you what is the smallest value of B. So you know that the remainder is 19, right?
Yeah.
So can the number B be smaller than 19 or must it be bigger than 19?
Can be smaller.
It can be smaller, is it? Okay, let's take a look at this. 91 divided by 8, 11, remainder 3. Correct? If I take 91 divided by 2, I will have 45, remainder 1. Nicole, do you realize that the remainder is always smaller than the divisor?
Yeah.
Because if the divisor is smaller, you will continue dividing, right? So do you think the number B, okay, now you're taking A divided by B, 2, 2, 1, remainder 19. Do you think the number B can be smaller than 19?
No.
No. So yes, you're correct. So let me get rid of this. So what must we say? Since we will say that B must be bigger than 19. Therefore, the smallest value of B, what is the smallest possible value of B?
20.
20. There you go. Very good, Nicole. You have any questions about this?
No.
All right. Well done. What about the rest of you? Anyone have any questions about this? Okay. If not, I will give you 2 minutes to do the question number 13. Give me your answer in the chat. Your time starts now. Okay, Malcolm, let's do question 3. What must we do first?
895 minus 13 and 1409 minus 23.
Yes, we minus the remainders so that both of the numbers will then be divisible by n. Then what should I do once I have these two numbers which are divisible by n?
The highest common.
Find the highest common factor. So n will be the highest common factor of 882 and 1386, which we are going to find by using what method?
Ladder method.
The ladder method. Yes. So 882 and 1386. Let's divide it by what number do you want to use first?
2.
2. Divide by 2. 441 and 650 plus 38. No. Plus 650 plus 43. Okay. So then what's the next number you want to use?
3.
Yep. Then what's the next number you want to use?
3 again.
Yep. Then what's the next number you want to use?
7.
Yep. What's the next number you want to use?
Is prime. So you cannot divide anymore.
So you can't. Very good. You have to stop here because both of these cannot be further divided. Let's look at this. So what should I do to all those numbers that I've circled? Add them together, right?
Yeah.
Yes?
Yeah.
Add them together, right?
Yes.
And then my HCF is what? 15, is it?
No.
What should I do? You don't know?
Yeah.
Multiply them together. Okay, tell me, what is my HCF?
Wait. 1, 2, 6.
Very good. Well done. Malcolm, you got it. Good job. So how do you find this? Easy?
A bit.
A bit. Okay, good. All right, students, this is the same as example 2. It's also the same as practice 1, which we have already done. Okay, now moving on to question number 4. Can I ask Kaden? So, Kaden, let's take a look here. Can you tell me what is the divisibility rule of 11? Do you remember?
11 is take the alternating sum of digit of n.
Yes.
If it is divisible by 11, then yeah, it's divisible by 11.
Yes. Okay. Very good. You find the alternating sum of the digits. So, for example, if you have the number 1269, because these are the digits that they are giving us. So if you have 1269, then the alternating sum will be 1 plus 2 minus 6 plus 9. Yes or no?
Yeah.
No.
Wait, what?
No. What is the alternating sum?
1 minus 2 plus 6 minus 9.
Yes. Okay. This is wrong because there are two positive numbers there. I need them to be positive, negative, positive, negative. All right. This is wrong. So if I have 1269, what do I get?
Negative 5.
1 minus 2 plus 6 minus 9. Then you will get negative 5.
Yeah.
Yep. No. No, no, no. Negative 11 plus 7. What is negative 11 plus 7?
Negative 11 plus 7 is negative 3.
Let's take it one by one. 1 minus 2. What is 1 minus 2?
Negative 1.
Okay, negative 1 plus 6.
5.
5 minus 9.
Oh yeah, it's negative 4.
Okay, negative 4. Now, there are different ways to permutate this. Okay, there's like maybe 1 minus 6 plus 2 minus 9. What do we get?
1 minus 6 plus 2 minus 9 is 12. Negative 12.
Yes, negative 12. Okay, what is, let's permutate it again. Let's try 1, 9, 2, 6. What is the alternating sum?
Uh,
Well, it's
negative 12.
yes, it's the same, right? This is negative 15, right?
Because
Okay.
there's a positive 2 and there's a negative 9 and negative 6.
So you see the negative 9 and negative 6, it gives you negative 15. And you look at the positive 1 and the positive, it gives you a positive 3. Both of these have the same answer. Correct? Both of these are the same.
Yeah.
Okay. What other things can we try? Let's try 9 minus 1 plus 2 minus 6. What do we get?
This is 4.
Yes, positive 4. Well done. So actually, you know what? None of them are divisible by 11, right?
Yeah.
But are we trying to find something that's divisible by 11?
Yes.
No.
Oh, the remainder is 4 then.
Yes, the remainder is 4. Okay, so which of these, do I want to use negative 4 or do I want to use positive 4?
4. Positive 4.
Positive 4. Okay, sure. Okay, let me just tidy up first. So we have tried all these permutations. You want to try positive 4. That means you're telling me that if I take 9, 1, 2, 6 divided by 11, you are saying that the remainder should be 4, right?
Mm-hmm.
Come, let's try. 11 times 8 equals to 88. 11 times 2 equals to 22. 11 times 9 equals to 99. What is 106 minus 99?
7.
What's the remainder?
7.
Oh, whoops. It's not 4.
So
Right?
it's -4.
Okay, let's try the -4 now. 1269 divided by 11. Oh, very good. The remainder is 4 indeed. So students, we should be using the one with a -4, the alternating sum, which equals to -4. So let's do that. Okay. That means the first number that we can use is 1269. Can you tell me how many 4-digit numbers will give us the same alternating sum, which is -4? I'll give you the first example. I can permutate it like that. I can switch the position of the 2 and the 9. Okay? I can switch the position of 2 and the 9. Why? Because do you notice that this position is even? Sorry. The first digit, this is the odd digit because it's digit number 1. Digit number 2 is an even digit, digit number 2. Digit number 3, it's an odd digit. Digit number 4 is an even digit. Do you notice that the even digits are all negative? Kaden?
Yes.
Okay, the even digits, the digits at the
But 6 is not an odd number.
I'm saying that the digit in the even position. This is the first digit. This is the second digit. This is the third.
Oh,
This is the fourth digit. This is an odd number. This is an even number. So the digit in an even position is 2. The digit in an even position is 9. The digit in the odd position is number 1 and number 6. Do you realize that the digits in the even position is all negative? Yes?
yes.
The digits in the odd position are all positive. So when I do my permutation, I need to make sure that they stay where they are supposed to be. The 6 and the 9, sorry, not the 6 and 9, the number 2 and the number 9 must always be either in the second number, or it must be the fourth number. You agree?
Yeah.
So that's why I'm swapping the 9 and the 2. They can swap with each other. The moment I do something like this, then I'm wrong. Because now the 9, do you notice that now the 9 is going to be positive instead of negative? Yes?
Yeah.
Okay, good. So can you tell me what is another number that we can permutate? What else? I already swapped the 2 and the 9. What else you want me to do?
6912.
Swap the 1 and the 6. Very
Yeah.
good. What else can I do?
Uh, uh,
Why not you just swap back the 9 and the 2 again?
oh yeah.
What do I get?
6219.
Yeah. So how many possible digits are there?
5.
No. How many possible numbers?
Oh, 666.
No.
What?
How many possible numbers when divided by 11 gives you a remainder of 4? One.
4.
Yes.
I said 4. I said 4 the first time.
I think you said 6.
I
Okay.
said 4.
Very good. Well done. So the answer is 4. So, okay, then how was this, easy or difficult?
Easy.
Easy, yeah. Okay, good job, Kaden. Anyone has any questions? Raise your hand. Anyone? Now, some of you might be wondering, does it mean that if the alternating sum is 4, that means the remainder is 4? Well, as you have seen, no, it's not the case. I tell you what, in order to be 100% sure, why not just test it out? Okay, because right now when the alternating sum is 4, it actually gave us a remainder of 7. Okay, which is not surprising. 4 plus 7 is still 11, right? Now this has something to do with modulo. Modulo we'll learn next time. We'll learn modulo next time. For now, just test it out to be sure. Moving on to example 3. All right. So students, they're giving us a 5-digit number. They are not telling you what is the third digit and what is the 5th digit. And they're asking you to find x and y, right? It says that 10x3y is a multiple of 21, which means that it is divisible by 21. Is there a divisibility rule for the number 21? I don't think so. So what can we do? Anybody knows? Raise your hand. There's no divisibility rule of 21. How am I going to tell whether this number is divisible by 21? Anyone want to guess? Raise your hand. Nobody? Aiden? Okay, Aiden, what can we do?
5 is divisible by 7 and 3.
Correct, Aiden. Very good. Well done. So as Aiden have said, oh, by the way, students, if you want to raise your hand, right, you better click the raise hand icon. If not, I can't see everybody's screen at the same time. Okay, everyone look here. 21 is 3 times 7, right? So we just have to find out whether this number is divisible by 3 as well as 7. So why not? Aiden, you help me out, okay? First, we are going to find out if it is divisible by, I'm not, okay, I don't mean to say that. I'm not trying to find out if it is divisible by 3. I already know that this number must be divisible by 3. What are the conditions that are required for it to be divisible by 3? So what's the rule of divisibility of 3, Aiden? Find the sum
Find
of...
the sum of all numbers and check if it's divisible by 3.
Okay, so we call it digits, okay? Sum of digits.
Okay.
Okay, let me ask you something. Is this a number?
Yeah.
How many digits does this number have?
3.
Do you know what's the difference between a digit and a number?
Yeah.
Yes, the entire thing is called a number, but whatever makes them up, they are individual digits. Okay, let's find the sum of digits. That means I have to take this digit plus the next digit plus the next digit plus the next digit plus the next digit. What will I get?
4 to 4, 3. Or something divisible by 3.
Very good. You will be getting something that's divisible by 3. Can you simplify this for me in terms of algebra?
4 plus x plus y.
Yes. Okay, so I will end up with my x, my y, and I'll end up with 4. So therefore, we're going to say that the number 3 divides this number, x plus y plus 4. And that means that x plus y plus 4 could be equal to certain things which are all divisible by 3. These are all divisible by 3, right, Aiden?
Yes.
Is 0 a possibility?
Yeah.
I don't see how. You're trying to tell me that x is -2 and y is -2, is it? Then I get 0. Is it possible that I have this number 1, 0, x, 3, y? Is it possible to have this
No.
number? This number does not exist. So can x and y be negative?
No.
No. It should, you see, the numbers, these digits should be digits from 0 to what? Aiden?
0 to
100. That means 10, let's say x is 99. 10x 3
0 to 10. So 0 to 9.
0 to 9. Correct. Okay, x and y must be from 0 to 9. Okay, it is a single digit. You cannot give me double digits here. So if x is a positive number from 0 to 9, is this possible? X plus y plus 4 equal to 0.
No.
No, it's not possible. Okay, because you cannot tell me that this is negative, right? Is number 3 possible?
Can.
How?
You put x plus 3.
Huh? What?
Wait. Meeting.
X plus y plus 4 equal to 3. So that means x equals to what? X equals to 1, y equals to 0. Or x equals to 0, y equals to 0. Then you plus 4, you get 3. Is it possible for x plus y plus 4 to be 3?
No.
No. Is it possible for x plus y plus 4 to be 6? Let's say x equals to 1, y equals to 1. You
6.
add them together is 6. Possible or not? Possible or not?
Can.
Okay, good. What about x equals to 2, y equals to 0? Then you plus 4. Does it give you 6?
2 and 0.
2 plus 0 plus 4 is 6,
7.
right?
Gives you 6.
Yeah. So there's many different possibilities that can give us the answer 6. Definitely 6 is possible. 6, 9, 12, 15, 18, they are all possible. What about the number 21? Is it possible? Is the number 21 going to be possible? Let's say this is x is 9, right? Then can you get 21? Then what is y? How do
8.
9 plus 8 plus 4 is 21. So is 21 possible?
Yes.
Yes, 21 is possible. What about 24? Is 24 possible?
24 can.
Can. How? You get 9 plus 11 plus 4, right? Then you get 24, right? So you're telling me that the number y equals to 11. So my 5-digit number becomes this 11 like this. So now it becomes a 6-digit number now.
No.
What is the value of what is the possible value of x? From 0 to
9.
and what about y? From 0 to
9.
can y be 11?
No.
Cannot. So let's say let me give you the maximum value of x. Let me give you the maximum value of y. What answer do you get? 9 plus 9 plus 4.
23.
No.
No, 22. 22.
So can I ever get 24?
No.
So is 24 possible?
No.
No. Okay, good. So now we realize that the possible values of x plus y plus 4 are all these. Therefore, x plus y could possibly be 2. What else?
2. 2. 5. 8. 11. 14. And 17.
Very good. You just need to minus 4. Yes, you are correct. Okay, now we have already determined that this number is divisible, must be divisible by 3. We must also say that it is divisible by 7. What is the rule of divisibility of 7? You separate the last 3.
Celebrate the last 3 digits.
Yes. Okay, you celebrate the last 3 digits and you take, and what do you do?
And then you
Find the difference between the last 3 digits and
And the other digits.
yes, and the other digits, which is 1, 0. Right, Aiden?
Yeah.
Okay, good. Can you tell me what does this give us? Can you simplify this?
It's equivalent to. Actually, no, it's not.
Can you simplify or not?
No.
Okay, let me ask you something. Let me ask you something. This is the hundredth digit.
So you want to verify 100?
This is the tenth digit, right?
Yeah.
This is the ones digit.
Oh, you
What is
want to find. So you
Ah.
have the x plus 10 plus 30 plus y.
Correct. So you are telling me that the value of 3 is 30, right?
Yeah.
Can you help me to minus 10? What is 30 minus 10?
20
So what will I get?
x 20y.
20y. Is it?
Yeah.
Wow,
2y.
very good.
Y.
2y. So that's how I simplify it, okay? Okay, we have simplified this. Therefore, we must say that 7 divides x2y. And what is the possible value of x2y?
Can be.
Okay, so what is, okay, 7 divides x2y, and therefore, what are the possible values of x and y? Right, x and y could, okay, x and y could be equal to, okay, let me give you one first, 7 and 1. So, for example, x equals to 7, y equals to 1. Is
Yeah.
this divisible by 7? Definitely, because 700 can be divided by 7, and the number 21 also can be divided by 7. So this is definitely possible. Can you give me another example?
Let's see.
4 and what? Okay, I'll help you with the first one. You tell me the second one.
4
4,
and 4. 4 to 4 to 0.
4 and 0. Ah, very good. So you are telling me that x, okay, this is x to y. So 4 to 0. This is going to be 4 to 0 is divisible by 7. Yes or no?
Yeah.
Okay, but I'm not going to write this down. I'm not going to write this down. Why? Because I need to make sure that x plus y equal to any of those numbers. If I take 4 plus 0, what's my answer?
4. Which means it cannot.
Which is wrong. Okay, so it cannot be 4 and 0.
How about 4 and 7?
Very good. If you take 4 plus 7, you get 11. Yes. And yet you know that 4 to 7 is divisible by 7. Very good. Okay, what else? Give me just one more. I would say maybe 8 and what? 8 and so you have 8, 2, and something.
8 to 6.
Yes, 8 to 6 is divisible by 7. Very good. And you also realize that 8 plus 6 equals to 14. So you are satisfying the condition above. You are correct. So these are all the possible values. What is the smallest, the minimum, the smallest possible value of x plus y? What do you think?
8.
Correct. Well done, Aiden. You solved it. How do you find it? Easy or difficult?
A bit, not really that easy. This
Yeah,
one's a bit harder.
correct. Okay, but well done. You got through it. Good job. Yes, Janelle, you have a question.
But then 420 can be divided by 21.
Oh, okay. 420 can be divided by 21. So that means x equals. Oh, okay. But if it is 420, that means x equals to 4, y equals to 0, right, Janelle? Okay, come, let's see. 1, 0, 4, 3, 0. Oops. Uh-oh. Doesn't work, right, Janelle?
Oh,
So basically what we are trying to do, Janelle, we are actually trying to come up with the very first condition. Okay, this is condition number 1 that you must satisfy. You must satisfy the condition that x plus y equal to 2, 5, 8, 11, 14, or 17. That's the first condition. The reason for this is it must be divisible by 3. You understand? So that's the first condition you have to satisfy. The second condition is x2y must be divisible by 7. Okay. And therefore, we came up with all these numbers because we know that these are divisible by 7. But if you are divisible by 7, and yet you are not divisible by 3, can you be divisible by 21? Cannot. You have to be divisible by both 3 and 7. So you must satisfy both conditions. Okay? Very good, Janelle. And anyway, just now when Janelle said that 420 is divisible by 7, that means is divisible by 21. That means 21 divides the number 420. When she was saying that, then I was thinking to myself that yes, that's true, but the question is not asking you to divide the 420 by 21. The question is asking you to divide this number by 21. So whether 420 is divisible by 21 or not is not relevant. Okay. So let's move on to the next one, students. Okay, Alistair, can I ask you to help me with this? Now, they're giving us a 9-digit number, very long number, right? And they're asking you to make it divisible by 72. Is there a divisibility rule of 72?
I guess.
You guess. No, there isn't. The divisibility rules are all here. And I do not see the number 72. Right? I don't see the divisibility rule of 72 here. So what should I do? If they want me to make something divisible by 72?
I have no idea.
Well, just now, we wanted to divide something by 21. Is there a divisibility rule of 21?
Oh, I understand now. I know.
Okay. So what should I do to 72?
I'm not really sure to say, but I find like the multiples like times it. Let's see.
So what is 72? 8 times?
Wait, 8 times 9?
Yes. Okay. Do we have a divisibility rule of 8?
Yes.
How about divisibility rule of 9?
No. Wait. Yeah, I don't have.
Don't have hand.
There is.
And what is this rule?
Huh? Okay.
What is the rule of 9?
The sum of digits.
Yes, find the sum of digits. Make sure it is divisible by 9. Correct? What is the divisibility rule of 8?
Observe the last 3 digits of the number.
Yes, correct. Okay, make use of the divisibility rule of 9 and the divisibility rule of 8. And we can solve this question. So first we start with divisibility rule of 8. And we must make sure that this number is divisible by 8. So what is the rule again for divisibility rule 8?
Find
Find
the last 3 number.
last 3 numbers. The
Of
last 3
10.
digits. Last 3 digits is, what are the last 3 digits?
Last 3 digits are 11, 1 and B.
11B. That means the number 8 should be able to divide the number 11B. And therefore, what is the value of B? Definitely not an odd number. It can either be 2, 4, 6, or 8, or 0. Can it be 0?
No.
Can it be 2? 1, 1, 2. Can this be divided by 8?
Yes.
Yes, because when you split it up, it gives you 80 plus 32. You know that 80 is divisible by 8 and 32 is divisible by 8. So the entire number 112 should be divisible by 8. So B equals to 2. You already found B. Now let's try to find A, shall we? The next rule is we must make sure that it is divisible by the number 9. And what is the rule of 9? Find the... How do you test whether a number is divisible by 9, Alistair?
Find the total,
Find the sum of
all the digits.
the digits. So we need to take what? A plus what?
A plus 1 plus 9 plus 9 plus 9
Can you speed up?
plus 3 plus 11
Ah, plus
plus 1 plus 1 plus B, or is it 2?
very good, Alistair. You are correct. But I'm going to erase this. Ooh. And I'm going to just do this. Do you know why?
This is 9 can be divided by 9.
Yes, because you already know that the number 9 is divisible by 9. So why am I wasting my time adding it? I don't need to waste my time. Just skip all the number 9s. And then, do you know what is the value of B?
Maybe B, wait, B or D? Yeah, B.
What is the
2.
value of B?
2.
So what do we get? A plus what?
A plus 1 plus 3 plus 1 plus 1 plus 2.
Yeah, can you tell me what? Help me to simplify everything. I'm not going to write all those numbers again.
Okay. 8. Wait,
Yes,
8.
it's 8. So now we know that the number 9 should divide A plus A. Therefore, what are the possible values of A plus 8? The first thing we always do is we say 0 is always included. Because if the answer, because 0 can always be divided by 9. What else can be divided by 9? The number 9. What else can be divided by 9?
18.
What else can be divided by 9?
8, 27, 36, 45, 50.
Oh, yes. All the multiples of 9, right?
Yes.
Now let's test them out. Can A plus 8 be equal to 0?
What? No.
Why not?
8 plus 8.
A plus 8. Can A plus 8 be equal to 0? Is it possible? Well, if you want 8 plus 8 to be 0, then A must be negative 8.
Oh,
If A is negative 8, that means this 9-digit number is going to be minus 819999311B. And that is not going to happen, okay? So it's not possible. Is it possible for A plus 8 to be equal to 9?
no.
Yes, because A is 1. A equals to 1. 1 plus 8 is 9. This is definitely possible.
Okay.
Is it possible for it to be 18?
Yes, plus. Wait, no.
So A is 10, right?
Yeah, it cannot. It cannot be double digit.
Yeah, because A cannot be a double-digit number. So this is impossible. What about 27?
No.
Yes, and anything greater than 27 is also impossible. Okay, so therefore, okay, what is the value of A?
Value of A can be what? 8. Yeah, 1.
1, yes, because 1 plus 8 is 9, okay? Therefore, A equals to 1. What is the question asking you? Find the...
Difference between A and B.
So, what is the difference between A and B?
1.
Correct. Well done, Alistair. How do you find this question? Doable?
Easy.
Easy. Okay, good job. Anyone has any questions? Raise your hand. Okay, then let's try the next page. So it is again the same type of question. You just need to make sure that you satisfy the conditions. Okay, so can I just ask Andriel? Andriel, 99 equals to something times something. What is it?
11 times 9.
You are correct. 9 times 11. So we need to make sure it is divisible by 9 and divisible by 11, correct?
Yeah.
So let's make sure it's divisible by 9. How do you do that? What's the rule? Find the sum of?
Find the sum of the digit.
Yes, okay, let's find the sum of the digits. 2 plus 0 plus 0 plus 3 plus... Okay, let's just call them x and y. Okay, x plus y. Let's just call them x and y. So then what do I get? I get x plus y plus... What?
2
Can you simplify everything?
plus y
Plus
5.
5. Okay, because 2 plus 3 is 5. And of course, the zeros, they mean nothing. So then we know that 9 must divide x plus y plus 5. And therefore, the possible values of x plus y plus 5, what could they be, Andrea? What is divisible by 9? You know that x plus y plus 5 must be divisible by 9. So x plus y plus 5 must be equal to what? One possible, just tell me one possibility first.
45.
45, yes, but we usually start from the small numbers. We usually start from 0 because 0 can divide anything. Yes or no?
Yeah.
0 can be divided by anything. So we always start from 0. We always try to start from the smaller numbers. Tell me what is after 0 that can be divided by 9?
9.
9. What else?
18.
Yes, what else?
27.
Okay, very good. Okay, so is it possible that the answer is 0? Is it possible that x plus y plus 5 will give us 0? Yes or no?
No.
Why not?
Because
x and y cannot be,
0.
they cannot be 0.
9.
X and y, they cannot be what? They can never be negative. Correct?
Yes.
So if they cannot be negative, are we able to get 0?
No.
No. So 0 is out. What about 9? Could it be 9?
Yes.
Could it be 18?
Yes.
Could it be 27? Well, let's try, okay? What is the maximum value of x?
The maximum value of x.
You don't know.
Mm,
Any digit. There's only 10 possible values of x, right?
9.
Yes, the maximum value is 9. What is the maximum value of y?
9.
So when you take them, you add them together, will you be able to get 27?
No.
No. So 27 is out. The only possible values of x plus y plus 5 is going to be 9 or 18. So therefore, the possible values of x plus y is equal to what?
9 and 18.
No, that's for x plus y plus 5.
Oh.
Now I'm
For
getting...
4 and 13.
Yes. 4 and 13. Yes, those are the two possible values of x plus y. Very good. Now we are going to figure out with the divisibility rule of 11. Divisible by 11. Okay. How do I know whether a number is divisible by 11?
Take the alternating sum of the digits.
Correct. The alternating sum. So we start with this plus this minus this plus this minus this. Yes.
No.
Very good. You didn't get tricked. Okay, that's correct now. And if I simplify this, I'm going to get this. Okay, now it is simplified. We must make sure that 11 divides this. So, what is the possible value of x minus y minus 1? Remember, we always start from, sorry, 1.
0.
Oh, must make sure it's divisible by 11. What's the next
11.
number? Yes.
22.
Oh, very good. Come, let's test it out. Let's test it out. Can you divide? Can this ever become 0?
No.
Cannot. Well, if this is 1 and this, wait, sorry. If this is 2 and this is 1, what will I get?
Oh. 0.
So it's possible to get 0, right?
Yeah.
Okay. Is it possible to get 11? Let's say I give the maximum value of x. What is the maximum value of x? 9. Okay, you minus 0, you minus 1. Will you ever get 11?
No.
So is 11 possible?
No.
What about 22?
No.
That's even worse, right? It's even bigger, right? So the only possible value is 0. So now we know that x minus y must be equal to how much?
0.
No, that's x minus y.
Negative 1.
No, I'm getting rid of this negative 1. How do I get rid of a negative 1? How do I make a negative 1 disappear? By adding 1. Yes, Embriel? If I take this, I plus 1 on both sides, then what do you think will happen to the negative 1?
0.
It will be gone. Yes. So I add 1 to both sides. This will be gone. And what happens to the other side?
It becomes 1.
So what am I left with? X minus y equals?
1.
Yes. So I'm just adding 1 on both sides. And I found out that x minus y must be 1. So can you tell me what is the 2 digits x and y? You look at all the conditions that we have. This condition and this condition. Can you help me to find out what is x, y? What is x, what is y? They must add up to, when you add them up, x plus y, you either get 4 or 13. But when you minus them, x minus y, you're supposed to get 1. Think of a number that can fulfill these conditions. If anyone knows, can you all type it in the chat? If anyone else knows, can you all type it in the chat? What is x? What is xy? Okay, then I'm sorry you got it wrong. Janelle, you got it. Okay, Janelle, well done. Malcolm, well done. How about you, Embriel? Okay, let's do it step by step. Let's try the number 4, okay? How do I get 4? 2 plus 2, right?
Yeah.
But if it is 2 plus 2, will I get 1 if I take... No, I will not get 1 if I take x minus y. So it's out. What is 3 plus 1? Is 4, right?
Yeah.
But if I take 3 minus 1, will I get 1? So is it possible for it to be 4?
No.
Let's try 13. Which two numbers add up to 13?
7 and 6.
Then when I take 7 minus 6, do I get 1?
Yes.
Okay, what is xy?
7 and 6.
So what number is this? 76. Very good, Embriel. You got it. It satisfies everything. You take 7 plus 6, you get 13. You take 7 minus 6, you get 1. Everybody's happy, right? Okay, anyone has any questions? Raise your hand. No? All right, then let's try the next question. Okay, students, over here, we have 2011 digits. What a long number. It's a 2011 digit long number. Wow. And they're asking you to determine if it is divisible by 13. Now, students, remember the number 7 and the number 13, they're very similar in their divisibility rule. Can I ask Caden, Hey, what happened to Kaden? Where's Kaden? There you are. Kaden, can I ask you what is the divisibility rule of 13?
Separate like
The last three digits?
3 digits.
Yes, correct. But what else? Okay, what other rule is there? Let's see. Let's take a look here. Do you think it will be useful for you to separate the last three digits out of such a long number?
No.
It's not useful. So let's use the other rule. What's the other rule?
Divide the difference between first and last 3 digits in every block of 6 digits.
Yes, very good. Okay, we just break them down into blocks of 6 digits. So let's take a look what we're doing here. Blocks of 6 digits. 1 0 0 1 0 0. This is a block of 6 digits. Yes.
Yes.
Okay, let's write it down. Consider each block of 6 digits. And we have 13 divides this. 13 divides 0. Am I right?
Yeah.
So every block of 1 0 0 1 0 0 is divisible by 13. How many groups? How many blocks of number of blocks? How many blocks of 6 digits are there altogether? What must I do to find out?
2011 divided by 6.
Very good. And I happen to have a remainder of 1 digit. Okay. So the remainder of 1 digit happens to be which digit? Do you know which digit is going to be? Aiden? Not Aiden, sorry, Kaden.
1.
Yes, this is the odd one out. This is the remainder one, the last digit. So now my next question to you is, if I divide this entire number by 13, what's the remainder?
Oh, no.
What's the remainder? Everything else is already divisible by 13. Only this guy is the odd one out. So when
1.
yes, the remainder must be 1. Very good. Because everybody else, they are already in their group. They already form a group of 6 digits. And every group of 6 digits are divisible by 13. So everybody else is divisible by 13. Only this guy is the odd one out. So when you divide it by 13, okay, since the last digit is the odd one out, which is 1, therefore the remainder when you divide it by 13 is going to be 1. So how do you find this? Is it easy, Kaden?
Yeah, very easy.
Very easy. Thank you, Kaden. Anyone has questions about this? So that's the reason why we have different rules. Because sometimes some rules are more useful than others. Okay, and when the number is very long, we are going to opt to use the 6-digit rule, the block of 6 digits. So let's try question 7, everyone. Can I give you 2 minutes? And type your answer in the chat. Your time starts now. Find what is the value of n. The smallest value of n. Now, Claudia, you know that the divisibility rule of 11 requires you to find the alternating sum. And if you want to find the alternating sum of this, it will be impossible to just...
Yeah, I changed this.
It will be impossible to do this, right? Because you don't know how many times it repeats itself, right? Right, Claudia?
Yeah.
What are we to do? I can't even find the alternating sum. How am I going to find the answer then?
I already changed.
Change.
Wait, the speaker thing is very soft, so I'm making it louder first.
Okay, testing. Can you hear me?
Uh,
Hi, Claudia. Can you hear?
now can already.
Okay, very good. I can't find the alternating sum. I don't even know how many 2005s there are. So how can I find, can you give me an algebraic expression of the alternating sum? Can we represent this in terms of the letter n? Okay, let's just do one first. Okay, come. Let's just do this first. What do we get?
-3.
Yes. Now, if you repeat this n number of times, then what do I get? If I repeat this n number of times, keep on repeating. 2 minus 0 plus 0 minus 5. Keep on repeating it n times. What will I get? Do you know? If I repeat it 2 times, what will I get?
Mm,
This is minus 3. This is also minus 3, right? What will I get?
-6.
So if I repeat it n times, what will I get? Okay, never mind. If I repeat it 3 times, what will I get?
-9.
If I repeat it 4 times, what will I get?
-12.
If I repeat it 5 times, what will I get?
-15.
So if I repeat it n number of times, what will I get? You just need to multiply -3 by what?
N.
Yes. Okay, so we can say that the alternating sum equals to -3n. But don't forget, you still have 2 digits left over at the back. You must continue your alternating sum. So you must continue plus and minus, continue your alternating sum because this is negative, right? Okay, so this was a -5. This was a -5. So you must continue your alternating sum. This is going to be positive. This is going to be negative, correct, Claudia?
Yeah.
Okay, so we continue our alternating sum. We get that. And we simplify it. What do I get? -3n and what?
Mm, plus
Huh? Plus,
wait,
plus or minus? What? 0 minus 1.
-1.
That's what we get. Any questions so far? Okay, so we know that the number 11 must divide this. But why not we just make our lives easier? Let's just say that the number 11 must divide this. It's the same thing. It's the same thing. Okay, because if this happens to be -11, then this is just going to be 11. Both of them are going to be divisible by 11. It does not matter whether it's negative or positive, but it's just easier if we get rid of all the negative signs, okay? So now we say that 11 can divide 3n plus 1. So can you tell me what are the possible values of 3n plus 1, starting from the smallest? Any number that is the smallest number that is divisible by 11 is?
0,
0. What else?
11,
What else?
22,
Oh, what else?
33.
Okay, let's stop there for a while. Is it possible that 3n plus 1 is going to be 0?
No,
Yes or no?
no.
No, because n cannot be negative. Okay, and n also cannot be a fraction because the only way for it to be 0 is n equals to -1/3. Then it will be 0. 3 times -1/3 gives you -1. So -1 plus 1 is 0. But n cannot be negative and also n cannot be a fraction. It will never give you 0. Is it possible for it to be 11? 3n plus 1 equals to 11. Is it possible? So you say n equals to, maybe n equals to 3? N equals to 3? So if n equals to 3, then 3 times 3 is 9, right? 9 plus 1 is what? 9 plus 1 is?
10.
Is it possible to get 11 then, in this case? Is there any value of n which is going to give you 11? Remember, it cannot be a fraction, right? It must be whole numbers. So if n equals to 3, you get 10. You cannot get 11. If n equals to 4, can you get 11?
No.
So can it is it ever going to be possible to get 11?
No.
No. Okay, what about 22?
22. Yes.
Very good. What is the value of n that will give you 22?
7.
Well done. 3 times 7 is 21. 21 plus 1 is 22. So n equals to 7. But should I continue to try for 33, 34, 44, 55? Should I continue to try?
No.
Because there might be more values of n. Do I need them?
No.
Why? Why not?
Because they say to find the smallest value of n.
Correct. Very good, Claudia. Well done. You got it. Good job. So students, there we go. Okay, you don't even need to try number 33. You got n equals to 7. Any questions? Raise your hand. All right, let's take a look at question 8. It is very much the same as question 7. So, can I get Vishwam? Vishwam, come, let's do this. So, what are we going to do for this? They want it to be divisible by 11. What must we find?
The number of times in 2000,
You must find the
smallest value of 2000, n.
the alternating sum, right?
Yes.
So 2 minus 0 plus 0 minus 8, what do I get?
-6.
So if I repeat this thing n times, what will I get?
-60.
Huh? Or if I repeat it n number of times, what will I get?
-6n.
Yes, -6n. And I must continue the alternating sum for the last few digits, right?
Yeah.
So will it be +6 or -6?
+6.
-2 plus 3. Simplify everything. What do I get?
-6n. +7.
Very good. So now I must make sure that 11 divides -6n plus 7. Now, I don't really like the negative sign there. Let me just multiply everything by -1. Then this becomes positive, this becomes negative. Okay, what are the possible values of 6n minus 7, which will allow me to divide it by 11?
11, 22,
Oh,
30.
you don't want 0, ah? You don't want 0?
Oh yeah, 0, 11,
20.
22, 33, 44.
Yes, correct. Is it possible for the 6n minus 7 to be equal to 0? Let's say n equals to 1.
No,
Cannot. N equal to 2, can it still give you 0?
no,
So it's not possible, right?
no,
Can it be 11?
no,
Yes or no?
no.
Why not? Why not? If n equals to 3, then what will happen?
Oh, okay.
Yeah, 6 times 3 is 18. 18 minus 7 is 11. So it's possible, right?
Yeah,
And they want us to find the smallest value of n, right?
yes.
So do I need to continue testing for 22, 33? So therefore, my answer is n equal to?
Great.
Very good, Vishwam. So fast, huh? Easy or not?
Yes.
Okay, thank you, Vishwam. Well done. Any questions, students? Okay, now, students, we are going to move on to one more question. I have a challenging question for you. But if you do not have time to stay back for the challenging question, you can go off, okay? And you can watch the video recording later. But if you have time, you want to stay for extra challenging question, then you are welcome to stay, students. Let's look at the challenging question right now. There we go. Okay, take a look at this. I would like to ask Janelle to volunteer for this challenging question. Okay, Janelle, there is a very long number which has 101 digits, and they are telling you it's divisible by 7. Can you tell me which divisibility rule are you going to use? Okay, let's go back to the divisibility rule of 7. they mentioned something about every block of 6. Remember, every block of 6. So in every block of 6 numbers, if the difference between the last 3 numbers and the first 3 numbers is divisible by 7, then the entire thing is divisible by 7. So let's consider each block of 6 digits. Okay? You already know that 666 minus 666 equals to 0. And you also know that 555 minus 555 equals to 0. And all of these are going to be divisible by 7, correct? So, Janelle, if that's the case, can you tell me how many blocks of 6 are there? How many blocks of 6 are there going to be? Blocks of 6 and blocks of 5. Okay, because both of them have 50 digits. So there's going to be the same number of blocks of 6 and blocks of 5. What should I do to find the number of blocks?
50 divided by 6.
And I will get a remainder of
2.
Okay, good. Now what does that mean? That means, okay, the first 48 numbers, the first 48 digits are already divisible by 6. The last 48 digits are already divisible by, divisible by 7, not 6, divisible by 7. So what are we left with in the middle? How many 6 are we left with in the middle? Because no, because 42 of them, 48 of them are already gone. Yes, so we are left with 2 6 and we are left with
2 5.
2 5s. Correct. We are left with 2 6s and 2 5s because the remainder is 2. We are left with 2 6s and 2 5s that are the odd one out. They are not part of a group. Okay, so we have this. So now we just need to consider the number that is left behind. This must be divisible by 6. So we are going to say that, sorry, I keep on saying 6. This must be divisible by 7. So we must make sure that 7 divides this. Now, can you use another rule of divisibility to determine whether this 66M55 is divisible by 7? If you have a 5-digit number, how do you know if it is divisible by 7? You separate the last, what? Separate the last how many?
The last 3 digits.
Very good. You separate the last 3 digits, okay? And you find the difference between the last 3 digits and the remaining digits. So you must find out. So therefore, we can say that 7 must be able to divide the difference between the last 3 digits and the remaining digits. Okay? Can you simplify this for me? M55 minus 66. Looks like 55 cannot minus 66, right? Can anybody have any ideas how is it possible for me to simplify this so that I can just get a 3-digit number instead of this long thing that I find hard to work with? Anyone can help me to simplify this? Yes, Kaden. You have an idea?
M11.
Huh?
M11.
But 55 cannot.
No.
But 55 cannot minus 66, right?
Negative. M negative.
Ooh, that's even worse. How can you have a negative number in the middle of a number? No,
How about 11M?
no, I'm sorry. Can't do that. No. Anyone else has any ideas? Gwen? Gwen, can I ask you something, Gwen? Hi, Gwen. Okay, Gwen. Oh, where's Gwen? Hi, Gwen. Are you there?
Yeah.
Gwen. Let me ask you something, Gwen. Can you have any idea how to simplify this? Like, because 55 a bit too small. If I have M55, let's say I minus 11. Very easy. I can just get the answer M44. Yes or no?
Yeah.
But now M55 minus 66 is too big. You have any idea of how to simplify, how to minus it? Do you know?
Times M55 by wait no.
Actually, it is something along that line. We must modify the M55. Gwen, can you just give me a number that is divisible by 7? Just any number that's divisible by 7?
49.
Okay, 49. If I were to take, okay, 49 is going to be a problem. Can I say 21 is
Okay.
divisible by 7? You agree?
Yeah.
Okay, you agree, huh? What happens if I take M55 plus 21? What will I get?
M76.
And now is this going to, wait, so now I plus 21. If this is divisible by 7, do you think that M76 is also going to be divisible by 7?
Yeah.
Why? Because,
Oh wait, no. Oh yeah.
why? Why yes?
Because 21 is 7 times 3.
Because 21 is divisible by 7, right? So
Yeah.
if I add the number 21, then the entire number is still going to be divisible by 7, right, Gwen?
Yeah.
Very good. So, Gwen, let's add 21. So I'll end up with M76 minus 66. What is M76 minus 66?
M10.
M10. Thank you, Gwen. All right. So students, we have now simplified our M. We have minus the 66. We got M10. So Janelle, what do you think are the possible values of M such that M10 is divisible by 7? Janelle, what do you think?
Oh wait, but
What do you think? M10 is divisible by 7. So what's the possible value of M, Janelle? What is can M be 1? Is 110 divisible by 7? No, it's not. All right, never mind, Janelle, you can just type. 110 cannot, right? What is the next one? Students, okay, why not like that? Everyone, can you all type? Oh, you can. Okay, Janelle is asking me a question. Just now we have this plus 21 equals to this. Janelle is asking me, why don't you just add 14? Sorry. Why not you add 14? We can. Okay, then you minus the 66. You end up with M03. You can. Very good. Okay, but I just happen to think of 21. You want to add 14, go ahead. As long as you are able to minus your 66, go ahead. Okay, good question, Janelle, good question. Everybody, can you type your answer in the chat? What is the possible value of M? Very good, Aiden. Zheng Yi and Brielle, yes. Claudia, try again. Janelle, correct. Now, I realize that everybody gave me the answer 2. Because 210 is definitely divisible by 7. Because 21 can divide by 7, right? Hey, you know something, students? There's another answer. And only Aiden gave me the other answer. Everybody else only gave me the answer 2. Very good, Janelle. 2 and 9. Well done. Because 910, you split it up. This is 700 plus 210, right? So it can also be divisible by 7. So the answer is the possible values of M are 2 and 9. Very good, students. You have managed to finish the challenging problem. Anybody have questions? Raise your hand. Nobody. All right, well done, everybody. Now, students, most importantly, please remember, memorize what are the divisibility rules, because if you memorize it, it saves you a lot of time and you can solve more complicated questions. 7 and 13, very similar. When you memorize 7, that means you have memorized 13. 4 and 8 are very similar. 3 and 9 are very similar. Number 11 is just a little different. It is the alternating sum. Okay, so go and do your revision, watch the lesson recording, and you will be very good at this topic. Now, if you have any questions, you can stay back and ask me. If not, I'll see you next week. Bye, everybody. Bye, Aiden. Bye, Talia, Zheng Yi. Bye, Nicole, Claudia. Bye, Aiden.